Our second lightning round talk. And so if I could get the students who are giving presentations at this morning's lightning round talk, please come up here, over here. And the quick lightning round talk on lightning round talks is 1.5 minutes per student to advertise their posters and research. They have no slides. There will be no questions. If you'd like to talk with them, please do so. You can go and stand over. Yeah, thank you. You can please do so at their poster session this evening. And with that, I think we're going to go ahead and get started with the high school group. And that's you? Yep. Okay, great. Come on up.
Hello, my name is Nye Lizis. I'm representing a team from Mount Horeb High School in Wisconsin. And we've been fortunate enough to participate in the XMAS program, bringing high school students into the fold this past school year for us. The research we've chose to focus on was taking a look at water on the moon, specifically localized water enrichments at silicic dome sites. And the main question we were following was whether or not all of the water observed at these sites could be attributed to an exclusively volcanic origin, or if other explanations for water sources would be necessary to explain the water seen at these sites. Our poster has been relocated to number 9, so please come by, take a look. We would love to talk with you and explain our research to you. There's 8 of us here, so you have no shortage of people to converse with. Yeah, I hope you're interested, and we'd love to see you.
Joseph mentioned he may not be able to make it this morning. Oh, there he is. Come on up.
Hi, my name is Joseph Samaniego. I'm from the University of Colorado Boulder, work at Survey Impact and LASP. The majority of my work focuses on space plasma instruments, specifically Langmuir probes. We're currently in the process of developing and testing a new double hemispherical Langmuir probe for the purposes of asymmetric space plasma measurements. Langmuir probes have been around for a better part of the past century and have been robust and well-used probes. However, they, when in unideal situations, they have been shown to have issues. Our hope is to fix those issues with our double hemispherical probe. Thank you.
Thank you.
Hi, my name is Garrett Schieber. I'm a student at Georgia Tech, and I'm part of the REVEALS project. I'm a mechanical engineer, and what we're studying is the transport of volatiles within regolith, which is a porous media. This is applicability to things like in situ resource utilization and potentially fundamental planetary science if we want to see how these volatiles are transported at different time scales. So that's my research. Come check out my poster and I can tell you more. Thank you.
Good morning, everyone. My name is Lin Zhisun, and I'm a PhD student from University of Hawaii, and I work with Dr. Paul Lucy. I mainly work on lunar remote sensing, and I have a poster today. It's about the lunar soil polarization. And if you're interested, please stop by. And we measured the polarized reflectance of 8 lunar samples. Then we built a radiative transfer model to reproduce this process. And for some lunar detection, when you're encountering large phase angles, you might be measuring the polarized reflectance instead of the real reflectance, and there's a difference between them. We are able to correct this difference. So please stop by. My post number is 11. Thanks.
Hi everybody, my name is Marina Gemma. I'm a second-year graduate student at Columbia University. I do my research in the Department of Earth and Planetary Sciences at the American Museum of Natural History in New York. But today I'm presenting a project on meteorite spectroscopy that I completed with Dr. Tim Glotch and his group at Stony Brook University. And we measured the visible near-infrared spectra of ordinary chondrite meteorite powders at simulated asteroid surface conditions. We varied the temperature of the samples and the grain sizes to see how the spectral features changed. And this work is part of a broader effort to create a spectral database of materials relevant to missions to airless bodies. So I'm at poster number 7. If you have any questions, please come and ask me. So, thank you.
Hello, everyone. Good morning. My name is Jordan Young, and I am a second-year grad student at Stony Brook University in Long Island, New York. My poster this year is on the effects of micrometeoroid bombardment experiments on the visible and near-infrared spectra of olivines. And the impetus behind this project is that as extraterrestrial resource utilization becomes more and more important, the need to identify phases via remote sensing becomes more important as well. And to that end, we need to understand how space weathering effects of airless bodies contribute to the spectra of these things to make more accurate predictions. And so, for this reason, I've been testing micrometeoroid bombardments out at the impact facility in Colorado Boulder, and I hope you'll come check out my poster, poster 21. Again, my name is Jordan Young, and thank you for your time.
Hi, my name is Dylan Macdougall. I'm a former undergraduate from Stony Brook University where I worked with Tim Glotch on a long wavelength correction to the thermal channels on LRO Diviner. Diviner has 3 channels that have an emissivity conversion for them so that we can use them for spectroscopy. The other 4 channels, which have been used for determining temperature of the surface on the moon, can also be used for spectroscopy, and there's additional spectral information in those channels. So with my new correction, we're able to use those for mapping, and that will aid in photo interpretation and quantitative identification of minerals on the moon. So if you're interested in this talk, I will be in session number 3 at 11 o'clock today. Thank you.
Hey guys, one more. My name's Elliot. I'm not up here to sign up yesterday, but you're gonna hear my shameless plug anyways. So I'm a graduate student at Georgia Tech, part of the Reveals team. The first letter in our acronym is for radiation, and I don't need to stress with this group here why that's important. It's a huge challenge to prolonged human space presence. So we break down radiation into 2 groups, shielding and detection. I'm on the detection side, and my advisors and I are looking at novel topological material systems. We're trying to see if we can use them as sort of a dosimeter model, and hopefully one that's somewhat kind of like a patch that we could integrate into the spacesuit at various locations to account for tissue specificity. Currently, we're looking at a neutron dosimeter. We're looking to utilize graphene's unique conductivity and boron-10's neutron capture reaction to get a active readout of cumulative radiation dose. So anyways, if that sounds like something you guys are interested in, my name's Elliot, and I'll be at poster 43. Thank you.
And one more round of applause for all of our speakers, please.